All right, welcome to chapter 3, where we're really going to get our hands dirty and code our very first program together. But before we do that, we need to install the software that we'll use in order to communicate to the computer. As I mentioned in the intro video, the type of environment we're going to be using for this class is called processing. What processing is a developer environment that allows us to write Python code and use some of their functions, or you can think of them as encapsulations, in order to draw with our Python code. So we're going to play around a little bit with that, but first I'm going to go over how you can install processing onto your machine. If you go through these steps and you're having problems, please stop by help hours or tutorial time and join the queue and work with either me or one of the TAs to get it installed on your computer, because you will need this software installed in order to do this course, because it's what we're going to do all of our assignments in, write all of our code in, etc., etc. Okay, I'm going to be going over how to do this on a Windows machine. On a Mac, it's very similar, if not simpler. That's what I was going to say. My words just were going too fast, so they got mushed together. But I'll go over it on Windows. If you are having problems with it on a Mac, just come to tutorial hours and we will help you through there, okay? So the link to download processing is on the course website here. It is, if you go into the section called course resources, the third item down, it's just download processing. If you click on that, it's going to take you to a website that looks like this. You can also Google download processing, or put in this URL if you want, which is just processing.org/download. And it should look like this. All you're going to want to do is click this big blue button to download processing for Windows. If you're on a Mac, it will say download processing for Mac OS, and it should be version 4.2 or something around processing 4. You can do this course with if you had processing 3 installed on your machine already, but we'll be using the processing 4 environment in all the videos. So if you want it to look the same, you really want to have it like, I want to say word for word, but it's not word for word. It's like image for image, what you see on the screen and what you see on your computer, then you'll want this processing 4. When you download that, it should end up in your downloads folder. And you'll see it'll have this little zipper over the folder, and it'll say processing 4.2 Windows x64. If you're on Mac, this will be something different. You'll notice the type of file this is a compressed file. So in order to use it, we need to extract the contents, or tell the computer to extract the contents for us. So all you need to do that is right click on that file, that compressed file you downloaded, and then hit extract all, and the pop-up that comes up. When you do this, it's going to ask you where would you like to extract all of these items to. If you just put it in the default area, it should show up in your downloads folder as well. And then you hit extract. I'm not going to do that because I already did this just to save a little bit of time. But if you are just leaving everything as default, going into your downloads, once you hit extract, it's going to pop up a new window and show that it's working on extracting all of that information out of that compressed file. And then you should get a folder without a zipper directly underneath it, same title, but this one's actually called a file folder. So if you click that, you'll see inside there's a folder called processing 4.2. You'll click that again, and then this is where you'll find the actual application. So you'll see there's 2 applications up here. The one that you'll want to click is this processing at the top with the little logo, not processing Java, just processing at the top. You'll note, so I'm just going to go back into my downloads for a minute, that if I click into this compressed file, I see the same types of things. But if you try to click on this, it's going to tell you, oh my gosh, it's not extracted. You need to extract it. It's going to start yelling at you. Because remember, computers are stupid. Computers need to be told very specifically what to do. We need to give them distinct instructions in order for them to achieve their tasks. And if we don't communicate with them in the way they're expecting, they're going to throw a hissy fit. They're going to tell us, you're doing something wrong and I don't know how to do it and I'm just not going to try. Right? And that's for a good reason. So if you're in here, if things aren't working, check to see if on the top of your Finder if there's an extract all button. That will decompress that folder for you. Or, again, you can just go through your downloads on the compressed folder, right click, extract all, select where you would like that to go, and hit extract. Either will work. And then you need to make sure that you're using the uncompressed folder, so it should just be a regular file folder, and you'll find that application. When you click that, you're going to double click on this processing application, and then it should bring up a program that looks like this. Ta-da! Cool. We are ready to write programs. Woohoo! And usually if I'm downloading a new development environment or something, I want to know that I did it correctly. So I'm going to put in a fairly simple command to the computer that I know should work and it will tell me if I did it right. The one that I'm going to use is the print command. So if you'll remember from the textbook, the print command we can use to display some information to our console. So when we're looking at this environment here, we have this big section with all this white area up here that's kind of like a notepad, and that's where we're going to be writing our code. That'd be like our notepad or our sketch pad, whatever you'd like to call it. Down here, this gray area is what we will call our console. So we, if we're using the print command, should see things from our console, from that print command that we want to display, show up down here if we did it correctly, okay? So when we are programming, we need to make sure that we are communicating in the way that the computer expects. So that means typing everything out, just like you would see in the textbook, symbols, white space, everything. And remember, it's just like a new language. So it's like if we were learning English for the first time, we have to learn all of those spellings. We have to learn how to structure sentences so that we can communicate with other people. That's what we're doing here. So it will take some time. Don't be upset if the computer says, oh, there's an error or oh, whatever. We will just figure out how to read those errors, how to adjust, and how to fix them so that we can talk to the computer the way we want to. So like I said, I'm going to check that my install worked. I'm going to put print, opening bracket, double quote, and then I'm going to just say hello. Closing double quote, and you'll see it changes the color, and then a closing bracket. So this is how we tell the computer to display anything in between these double quotes in our console. So we would expect it to say hello to us in that dark gray spot. Once I have that written, all you need to do to run the program is to hit this plus button, and it's going to go, ah, it's yelling at me. There's a syntax error, a missing semicolon, and you're saying, what? We didn't even talk about semicolons in the textbook. What is going on here? Why is it yelling at me? Because computers are stupid. There's a key thing that we forgot to do here when we set up processing. Processing is a software development environment. We can use a number of programming languages in that software development environment, and we have to specify to the computer which one we'd like to do. And how do we do that? Well, up in this top right corner, you'll see something that says Java. Now, in this case, it's not talking about coffee. It's talking about the programming language Java. And Java loves semicolons. So yeah, we have a communication error with our computer. It's expecting us to be speaking in Java, and it's expecting semicolons so that it knows when we're done telling it what to do. But we don't want that for this class. We want Python. So what we need to do to switch that is click where it says Java. You probably won't have the Python option yet. In order to get that there, you need to click on this Manage Modes. And then what you're going to do is look for this Python for processing. Python mode for processing 4. This one right here. And you'll want to click install. It'll take a moment to install. But once it's there, you'll be able to just go into this dropdown and click Python. And that's going to open up a whole new sketchpad for us We can repeat our print statement with our opening brackets and our double quotes, and we can cross our fingers and we can say, run. Ta-da! Success is ours. It is saying hello down at the bottom here. So you know that you did it right if you have Python up in this top right corner. You'll also only have a run and a stop button up here. You'll notice, I'll just move this over for a minute. When we were in our Java mode, we had a debug, a step, a continue, a stop. There were so many extra options. We don't want that for this class. That's a second year thing, is using Java. So we want to do Python. If you're having troubles getting them installed, stop by the help hours. We'd be happy to help you out with that, okay? I'm just going to exit out of the Java one so I don't accidentally bring it over and have the computer yelling at me about semicolons all day, because I do not want that, all right? Okay, so here, let me bring up the slides. We're going to move on over into our exercises now. We've already kind of talked about this, and you've seen an example of this, that we need to use a programming language to tell the computer what actions to do. In this class, we're going to use Python. We could have been using Java. We could have used Perl. We could have used Shakespearean if we wanted to, right? That is a true programming language. There's all sorts of different things. And the goal of this class isn't to master Python. It's to figure out how would we use Python to apply the principles of programming that we're going to be learning about here. So these principles that we're going to learn about are going to be universal for many, many, many of the programming languages that you will use throughout your career as a computer scientist, okay? Python is what we start with in first year. You'll be using it if you go on to 141 and 145. Java, as I mentioned, is one that you'd get experience with in second year. And there's many, many other computer science courses where we tackle different types of programming languages, okay? I'm going to go through a demo. We're going to draw some lines and shapes to the screen with processing in Python. So I showed you how we can put text in our console. But if you'll remember from the textbook, processing is really more powerful than just a console. We have the ability to use some of the functions that are built in to actually draw things to a canvas. And it's really, really powerful. So effectively what they've done is they've encapsulated a whole bunch of instructions for the computer into these different functions that we can just call by name, and it's going to display something on our computer for us. So it will, instead of just being text, we could draw lines and circles and squares and combine things. And it's all going to happen through this grid system that we went over in the textbook. So I'm just going to go back to my web browser here. And I'm going to pull up this virtual graph paper. But really, you could be doing this with a piece of paper and a pen or a pencil right in front of you. And you'll probably want to do this for most of your assignments. This is how we would visualize the canvas in processing as a graph. So we would have our x-axis, which goes across here. So the horizontal one would be an x-axis, and a y-axis, which goes up and down. And we can assign values to each of those junctions. So every time one of these darker blue lines crosses our axis, we could say that's a unit of 1 that we go up by. We'll just use a unit of 1 for this class because it's simple and we're not doing a advanced mathematician graphing class right now. It's just programming, and we want to know how we can predict what we'll be able to see on the canvas. And so every time I have that darker blue line crossing, I'm just giving a label on each direction here. 1, oops, 2, here we go. Oh, why am I having issues? Well, we'll just skip to 4, and then we'll come back to 3. I will win, computer. I will win, always. And this point right here, where the X and Y meet, is always going to be our 0, 0 point. So you won't see these numbers in the processing canvas, but when we're thinking about creating an image with our code, oftentimes we'll first want to plan out, okay, well, how would we map that image back into some sort of graphical format? And so you'll want to bust out these grids like this and start drawing shapes on there so that you know what information to feed to the computer. So for instance, one of the very first functions that we talk about in the text is this one called line, which draws a line to the canvas. And it takes 4 what we would call parameters, so values. We have an x value, I'm going to call it x1, y1, and an x2, y2 value. This is looking like a whole lot of math, hey? But it's not. It's just a little bit confusing to get used to your very first time having this different parameters in here and figuring out how do we communicate that to the computer. So say, I'm going to change my color here to orange. I wanted to draw a line that went like this. Oh, I have to pick a line first. Ta-da! A little horizontal line just like that. What I would need to do is figure out where in my grid is this point here and this point here. So where is this starting point and this ending point? And you could flip it. It's a line. It can go reverse either which way. And so how you figure that out is you start at the x and you say, okay, if I start at 0 and I go over 1, is that where that line crosses my axis? It is indeed. So in this case, my very first parameter for x1 would be 1. Now I need to figure out where that point would cross my y. And in this case, if I go starting at 0 and I go up 1, 2, 3, 4. That's where I want it, right? And same with this other side here. So we go over starting at our x. We're trying to find where this blue line crosses our x. 1, 2, 3, 4, 5. And where is it crossing our y? 1, 2, 3, 4. Okay. And we'll get more and more used to what that actually means when we are doing more and more examples of this. Now, I have a feeling some of you are yelling at me. Are you sitting there yelling at me yet? Because how did I draw this grid? I drew it how we would in a math class, where we have our origin kind of down in our bottom left corner and all of this space over here. In the textbook, is that where I was supposed to draw it? So the difference between kind of this type of grid that we would see in a math class and what we would see in processing is that the origin is actually flipped. So I'll make a purpley line for that. The x-axis actually goes, up here. Not this one down here. This is not it. So here, let me actually just make a new grid here. All the way over. We'll do it in purple because why not? And all the way down. And again, we could put in our coordinates. So it would start off here for our x at 0, 1, 2, 3, 4, 5, 6, 7, and same with this down this way. 0, 1, 2, 3, 4, 5, 6, etc. Now, if we wanted to recreate this line here, so we would say, okay, it goes over by 1 and up by 4 to start. 1, 2, 3, 4. And that, oh, where's my line? Here it is. Then goes over to 5 and up to 4. So here would be our endpoint. And I got that just because we went from our x, 1, 2, 3, 4, 5, and then up or down 4, 1, 2, 3, 4 to get it on the graph. So you see slightly different places, same type of idea. We're just kind of flipping it. So sometimes you'll hear me say, oh, we go up by this for x. It's because I'm thinking of it in the old math way. You can correct me every single time I say that. Say, Kim, Prof. Kim, you're wrong, you're wrong, you're wrong. We have to flip it and you're correct here. So we'd have it like this. So for all of our assignments where you're drawing things, for the exercises that we'll do right away, I highly recommend you start out with a grid and planning what these different coordinates would look like so you can grab those numbers to feed in as parameters, okay? Now let's try this. Let's see if our prediction of does it actually look like this works in processing. So I'm going to bring that over again. This was where we were testing the hello. I'm going to delete that. If I just went like this, line, what did I have for numbers here? We'll keep this on the side. 1, 4, 5, 4, and hit run. Is it going to work? Has it done anything? Okay, kind of. It's really hard to see, though. I mean, I know I'm old, but I'm surely not that old. This thing that popped up here is what we would call the canvas. It is our graphical output of our processing environment. So unlike the console, which would just be like text or numbers that we ask it to display, this is taking that function called line, running all of the tasks that are encapsulated in there that we don't need to know the details of, and generating an output. This is hard to see. I would like to make it a little bit easier to see. So what I'm going to do is I'm going to tell the computer, you know what? Whatever you're currently doing for setting how big this current grid is, it's too big. I want to change the size of my canvas, and I'm going to change it to be 7 by 6. So all I need to do that is type size, opening bracket, and then your values you want it to be. If I now hit run, we still have that line as my second option. You can see my little gray around here is a lot different than it was. So we're gonna typically not be working with things that are that small, but that gives you an example of what we're working with. I think the default canvas size, if I remember correctly, is 500 by 500. And what I want to do now is draw a circle in it. I'm going to leave my line because why not? But let's try drawing a circle. So I want you to think back to the textbook. What other options do we have for drawing shapes? We had line. There's 3 other ones we mentioned in the textbook. I'll give you half a second to try to remember them off the top of your head. You'll get very familiar with them, so it's okay if you don't. The other 2 are rectangle, ellipse, which are bigger shapes, and then point. So rectangle, remember from the textbook, it would be the X and Y coordinate of the top right, or top left, and the bottom right corner, I believe. And ellipse is the center coordinate and then the size. So if I wanted to do a circle, I could do ellipse, and I could do, let's make it in the middle of our canvas, so that would be 250, 250. Sorry. 250, 250. And let's make it big. Let's make it 100 by 100. Now, if I make those 2 values the same, then I'm going to get a circle. Because it's saying, what is the radius around all of those things? So see, here's my little line up in the corner, and here's my circle. All right. I've clearly been talking for too long because I'm starting to get a tickle in my throat. But what I'm going to get you to do is practice draw. Ooh, why is this causing so many problems? Here we go. Oh, there. Practice drawing all sorts of different types of shapes with processing. So get used to doing a line, drawing different kinds of lines, using the rectangle, using the point, using the ellipse. And then challenge yourself to try to draw a triangle and a hexagon. You already saw how to do a circle, so I won't need to give you that one. But start off on your graph paper. Figure out what those point values would be. A triangle, you probably need 3 lines to make that. So figure out what the coordinates and the points of those different lines would be, and then try to get the computer to recreate that, all right? And the hexagon will be the real challenge. There's so many sides to that, so many lines that you'll need. So play around with that and see what you can create. If you create anything extra cool, post it in the Discord or in the discussion board so we can all see it. and maybe try to recreate it ourselves. The solutions for the slides have the code for how we would go about making it. Might be different than how you do. You don't have to have the exact same numbers in the parameters, but you should have the same type of shape at the end of the day, all right? And if you have any problems with it, attend the help hours. All right, we'll see you in chapter 4.